What's up, guys? This is Jahangir from Midporium, and today we're going to get a basic introduction into average versus instantaneous velocity and understanding the differences between the two from a conceptual standpoint. We're also going to be going through a quick practice problem on average velocity, and for instantaneous velocity, that's the velocity we're going to be referring to throughout our whole pretty much physics unit. So average velocity, let's start off with that. So average velocity is basically going to be our displacement over time. So this is just theta, or change in x, delta x over delta t. So with average velocity, we're talking about the total displacement over total time. But with instantaneous velocity, this is velocity, so we'll put velocity at a certain time. This is what we're referring to. Instantaneous velocity is the velocity at that certain time, that certain moment. And pretty much as the word says, instantaneous, at that instant. Where average velocity is what we have from maybe like point A to point B. So I'll write a graph real quick just to help you visualize this. So let's say we had a graph something like this. Just a positive y-axis, positive x-axis, and let's just say we have a curve right here. So just a regular exponential curve. Now, if I were to label my points A, let's say this is A and this is B right here. So average velocity is going to be taking A and B over here, the slope from position A over here to position B. Now this represents x, this represents t, so this is going to be our position over time. And to find our average velocity, it's looking at this b minus a, those positions over t. So it's going to be something like, let's just say this is xb minus xa over the time at B minus the time at A, and this would be our average velocity. Now, what makes our instantaneous velocity different? Although this is the slope of our position versus time graph, which is our average velocity, our instantaneous velocity is going to be a tangent line of whatever instance we picked. For example, A, our instantaneous velocity is going to be the tangent line. So our instantaneous velocity is the slope of this tangent line over here, and that's our instantaneous velocity. So from a conceptual standpoint, it's really easy to differentiate instantaneous versus average velocity. Average is pretty much the average of what you're given over the total, and instantaneous velocity is at that certain time, or for this example, at that certain point A. What is the instantaneous velocity? So instantaneous velocity is what we're going to refer to as just regular velocity, and calculating these instantaneous velocity questions, you're going to be given a formula, and it's going to ask you at what time is the velocity going to be this, which we'll talk about in our kinematics videos. So to talk about average velocity, let's just say we had something like a swimmer swims 50 meters in 24 seconds, but double that, so double the time coming back. So coming back. So both of our questions is one, what is the average velocity? Down and back. So what is it individually if we're trying to ask for, or like each length, what's the average velocity going down 50 meters and coming back? Because we know that when we go from 50 meters from start to finish at the end of the pool, we're doing it in 24 seconds, but when we come back, we're doing it in 48 seconds. So that's one of our questions. And two, what is the average velocity of the entire swim? So just as a refresher, just real quick, we know that average velocity is going to be this displacement over change in time. So what's the average velocity going down and back? We finish at 50 meters and we started at 0 meters. So that's what that's going to look like. And we do it in 24 seconds. So we finish in 24 seconds. We started at 0 seconds. So this is going to equal 2.08 meters per second. Now what about coming back? Well, coming back, we're starting from those 50 meters. So actually we're starting from those 50 meters, but we finish at 0 meters. Okay, so the reason why we're starting at 50 meters and coming back at 0 is because we've said, and we've said it out loud, that our starting position is going to be 0 meters. When we go to the end of the pool, that's 50 meters. Now, when we're coming back, we're starting at 50 meters and coming back to 0 meters. That's one thing you really have to understand, is that you have to tell yourself, or you have to write down, where's your start point, where's your finish point. And then coming back, your start point is going to be where you finished off, and where you started over here is where you're finishing since you're coming back. So when we do that, we're starting off at 24 seconds and we end off at 72 seconds. You could also say, since we doubled the time, you could just put 48. So whichever one you're more comfortable with. And when we do the math, we get negative 1.04 meters per second. Reason why we have a negative is because we're going in the opposite direction from where we started. And since this is velocity, velocity is a vector, so that's why we have direction. Now, what is the average velocity of an entire swim? So I want you guys to pause this video and see if you can answer number 2. So the average velocity of the entire swim is going to be 0 meters per second. The reason why is because we said that average velocity is displacement over change in time. Now, if we look at the displacement, we go down and back. So we're coming back at where we started. And since we did that, we're not changing in displacement. We did have a total distance of 100 meters. If it said what's the total distance of the entire swim, or maybe it said what's the velocity at 23 seconds, we could find that. But since it's saying what's the average velocity of the entire swim, average velocity depends on displacement. We have 0 displacement. That means we have 0 velocity, and that's why the answer is 0 meters per second. So that pretty much wraps up an introduction to average velocity and instantaneous velocity. And this is another one of those basic topics that we have to understand in order to get to our kinematics units and everything like that. Because right now we're just building our base. Once we build our base, then we can level up to those other topics. So hopefully you guys learned something. And as always, a Pomodoro day will make you a doctor someday. I'll see you guys in the next one.